Welcome to the last section, section 4 in chapter 1. In this section, you will learn the calculations based on the design steps that you have learned in section 3. In the first step, we do not need to do any calculations, but we just need to determine the channel length that you will use. So as I mentioned in previous section, you will determine based on the technology that you use when you design your operation amplifier or OTA to be specific in this step. So the second one, we will determine the compensations capacitor. So let's assume the capacitance load is 4 picofarad, and therefore the compensation capacitance after calculated 0.22 times with 4 picofarad, we will get 1 picofarad. The third one, we will determine the tail current. So based on the desired slew rate. So in these calculations, the slew rate that we chose is 20 volt over 1 micro times with 1 picofarad from the capacitance that we have calculated in step number 2. So therefore, we get the current, the tail current at the transistor M5 is 20 microampere. Step number 4, we will determine the transconductance GM1 based on the desired gain bandwidth and also the capacitance that the compensation capacitance that we have calculated at the step number 2. So GM1 is given by gain bandwidth times with the compensation capacitance times with 2 pi. So the gain bandwidth that we desired here is 50 megahertz and times with the 1 picofarad that we have calculated before times with 2 pi. So we get the GM1 as 315 microsecond. Now let's move with step number 5, where we determine the aspect ratio of the differential pair of transistor M1 and M2. So W over L at M1 and M2 given GM1 squared. So GM1 here is based on the step number 4 that we have calculated before. And the mu n and COX here is depending on the technology that you use. So in my case here, my mu n COX is given by 363 micro and times with the tail current that we have calculated in step number 3, 20 microampere. So with that, we get the ratio of the width over length is 13.7. Okay. Step number 6, we determine the aspect ratio of the transistor M3 and M4 to achieve a positive ICMR. So the WL ratio that we get here is 0.7. Okay. The ICMR plus that we use here is 0.9 volt. The VDD is 1.8 volt. The voltage threshold is the maximum voltage threshold is 0.43 volts, and the voltage threshold minimum at M1 is 0.46 volt. The micro PCOX, for the PMOS that I have here is 262 micro. So the value of the micro PCOX, the voltage threshold will be varies depending on the technology that you use at your site. All right, let's move on to step number 7, where we determine the saturation voltage of the transistor M5 using the negative ICMR. So in this calculation, the negative ICMR that we use is 0.4 volt. Okay, And the mu n COX is similar as in step number 5, which is 363 micro. The WL we use as per what we have calculated in step number 5. However, the voltage threshold and a maximum voltage threshold here is 0.53 volt. And we will get minus 0.19 volt for the VD saturation. And the last step is to determine the aspect ratio of the transistor M5. With the given formula, we will rearrange it and calculate the W over L for transistor M5. So the ID5 that we use is the one that we have calculated. The mu NCOX is similar that we use in step number 5 and step number 7. The VD saturation, we used 0.19 volt as what we have calculated in step number 7. So therefore, we get 3.1 as the aspect ratio for the transistor M5. So there you go. We have done the calculation for our operational amplifier. Or to be specific, in these steps, we have calculated all the aspect ratio in order for us to design the OTA, 5T OTA, which is one part of operational amplifier. There you go. You have completed all the calculations that is needed in order for us to design operational amplifier. To be specific, the steps that you have designed previously and calculate is to design the 5T OTA, which is part of the operational amplifier circuit. Now you will move on to the next chapter, which is designing the OTA circuit using cadence tool. I'll see you in the next chapter where we will learn more on cadence tools. Bye!